Hi grade 11s, welcome to another one of our video lessons. Today we're going to carry on where we left off, and that is on page 130. So the previous video lesson I asked you guys to do activity exercise 1 and exercise 2. Okay, and that looked at scale and different bar graphs and scale graphs and word graphs that we can have on maps. Okay, so now we are going to unit 2, which is maps. So we're going to learn how to read a map and use grid references to find things on a map, and also use the scales to measure distances and find out what actual distances are on the ground. Okay, so pretty much what we were doing last lesson, we're just taking things a little bit further to actually work with maps and look for things. Okay, all right, so I'm on page 130. I'm going to read the first top bit for you. So most maps have grids superimposed over them. This grid is used to find the location of streets or towns and cities on a map. In many road atlases, the vertical grid lines are represented by numbers, while the horizontal grid lines are represented by letters. So if you guys are looking at this textbook with me on page 130, 131, on page 131, there's a map of Kruger National Park, and we have the grid reference that we just talked about. Okay, so if I refer to some place on this Kruger National Park, and I'll say, well, look at grid reference D3, and then you'll know where to look for this place. Okay. All right, so let's look at the worked example. I'll run through the worked example with you, and then you guys are going to do some exercises for homework. So number 1, a bar scale is used to calculate distances on a map. Other types of scales can be used, but these can become distorted if the map is enlarged or reduced in size. A. The measured distance between two towns on a 1 to 500,000 map is 6.5 centimeters. What is the actual distance on the ground between the two towns? Okay, so what they're telling us is that we have a scale of 1 to 500,000. Okay, it doesn't matter what units we're measuring in, whatever that unit is, if we measure 1 on the map, it will be equivalent to 500,000 in real life. Okay, so they're telling us that the measured distance between two towns on the map is 6.5 centimeters. Okay, 6.5 centimeters. That's what we measure on the map. So the scale says 1 to 500,000. So the actual distance will equal to 6.5 centimeters multiplied by 500,000. Okay, and that will give us 3.5 million centimeters. Okay, that's the answer. The question didn't say converted into kilometers or anything. It just said what is the distance between the two towns, and that is our distance. Okay, so they get, what do they get? 6.5 times 500, 3.25. Sorry, this should be a 25. Okay, they did convert it to kilometers, but again, it didn't say anything about kilometers. B, the distance between Grahamstown and East London as the crow flies is 15.5 centimeters on a 1 to 1.5 million map. Calculate this distance in kilometers. Okay, so now they've given us another scale, which is 1.5 million to 1. And they say that now the distance is 15.5 centimeters. So 15.5 multiplied by 1.5 million. Or actually, yeah, 1.5 million. Okay. So that if we multiply that, we'll get 23,250,000. Okay. And this is centimeters. But they told us let's convert it to kilometers. Okay. So 1 kilometer equals 1,000 meters. Okay. But 1 meter is 100 centimeters. So to go from 1,000 meters to centimeters, we need to multiply by 100. So we multiply by 100 and we get 1, 2, 3, 1, 2. So 100,000. So 1 kilometer is 1,000 meters, which is also 100,000 centimeters. Okay. So now what we're going to do is we're going to divide by 100,000. So that is 5 zeros over there. So we're going to divide by 5 zeros. So 1, 2, 3, 4, 5. And that will equal 232.5 kilometers. Okay. And that's exactly what they have in the book. All right, guys, so it's pretty straightforward. Get your scale, convert, well, rather first multiply, then get your answer, then convert to whatever we're asking you to convert. Okay, and then you can also go backwards. I can tell you that, well, this is the distance in real life. How much would this distance be in centimeters on a map? And all we would have to do is work backwards to where we started. And we did one of these exercises last time when we were doing exercise 1. Okay. All right, cool, guys. Number 2, use the map of the Kruger National Park on the next page and its surrounding areas to give the grid reference for each of the following landmarks. Okay, so really you just have to look for these landmarks and quote the grid for me. Remember, it's horizontal reference first and then a vertical. So it's a letter, then the number. So if we look for A, Baobab, so if I look on the map, Baobab it has a little purple triangle, and that is in grid reference B2. If we look for B, Sereni Bushveld Camp, okay, if I look for that, okay, I find that in D3, okay, and so on, guys. So you just look for the things, quote the map reference. Number 3, using the map of the Kruger National Park, explain how you would drive to the viewpoint near Dzundwini from the Punda Maria rest camp. Okay, so here when I give you a map reference, you have to use east, west, north, and south to guide me through where I'm going. Okay, so what you could say is that leave the front gate on the Pumba Maria rest camp and go across the first intersection. Turn left at the T-junction, take the first right turn, and the first right turn after that. At the end of the road, the viewpoint is clearly marked. Okay, so these guys obviously just gave you directions left and right, but you can also definitely involve north, south, east, and west. Okay, actually, if I'm looking at this map right now, they didn't give us any north or south, so I suppose you could only describe it by saying going left and right and so forth. Okay. All right, cool. So that's the worked example on page 131 and 130. So if you turn the page, we go to 132 and 133. There's exercise 3 and exercise 4. So these two exercises are on pretty much exactly the same thing that we just did in the worked example. Guys, I want you to work through them. They're pretty straightforward and easy. Get used to reading the maps, looking for things, understanding how the key works, and so forth. So give these a try, exercise 3 and 4, and we'll go over them in our next week's Skype lesson if you have any issues. Okay, then we can turn the page, 134 and 135. Now we have another type of maps. It's called an elevation map. Okay, now elevation map tells us how high or low we go above the sea level as we're covering some certain distance. So marathon runners and cyclists use these kinds of maps to determine how much uphill and downhill time they're going to have on their journey, and they can work out how hard they have to cycle in each stage and where they can take rest and so on. Okay, so we're going to look at the worked example on page 134. I'm going to work through this one with you, and then you guys are going to do exercise 5 on the next page. All right, cool. So a worked example, it says use the profile map below where the vertical axis represents the elevation in meters and the horizontal axis the distance traveled in kilometers to answer the following questions. Number 1, what is the maximum elevation of the rally's route? Now the maximum elevation, so if I draw this graph for you, okay, so if we look at our axes, on the vertical we have elevation, and that's measured in meters. Okay, and on the horizontal we have distance, and that's measured in kilometers. Okay, So that's what we have, and our graph starts off at about 1,000. So if we put scale on that, so it starts off somewhere here, and it basically goes up and down, and then, okay, whatever it does. The point is that we have elevation, we have distance, and we have different values. So now, as the race starts, we can see he's going uphill, uphill, uphill. Here he starts coming downhill, then he goes up, and so forth. So when we're asking you what is the maximum elevation of the rally's route, meaning that what is the highest point that he reaches on his journey. So the highest point would be somewhere over here. Okay, it's obviously not exactly the right drawing that I drew. So you guys must just look in your textbook. But if I look in the textbook, I can see that the highest he gets is just past 100 kilometers. Okay, so past 100 kilometers, you can see there's a little double peak there. And that's just under 2,500. So I would just say 2,500. And that's what they say in the solution as well. Number 2, at what distance does the answer to question 1 occur? Okay, so given whatever answer you had, at what distance, so how far away from the start does this happen? And if we look at the scale, it's between 100 and 150. So I would say it's somewhere at 110, maybe 112. Okay, there is some leeway when you guys are working with maps like this. There is, a few kilometers that I give you either way. But obviously for a question like this, you can't tell me it's 140 kilometers. It's way too far to the right. Okay, 110, 108, 112 would be okay. All right, number 3, determine the change in elevation on the steep downhill just before the 250 kilometer mark. Okay, so they're asking what is the change between elevation, so the highest and the lowest point, as we get to 250 kilometer mark. So if I'm looking on the map, I see the 250 kilometer map, the curve comes down like that. So what I'm going to do is I'm going to measure at the top of that tip. So I would say at about 230 kilometers, that's where the tip occurs. And I would say that is at maybe 2,400, 2,350, somewhere there. And then the bottom of that value, or as he gets down to the bottom, that would be maybe 1,100. Okay, so he descends from 2,400 kilometers or 2.4 kilometers to 1.1 kilometers. Okay, and you can even work out the difference and tell me what is the actual change in elevation. Okay, guys, so these map questions are really straightforward. You just need to understand how the keys and the maps, the scales work on the map, how to convert distances, and understand what we are doing. And then different types of maps also, you need to understand how to read them and what's going on. So we've done 2 types of maps, is the grid references and the elevation maps so far. So now you guys can do exercise 5, which is on the elevation maps. So it's exactly the same, almost exactly the same as the worked example that we did. Okay, and that will bring us to the end of our section for measuring maps and distances. So there's a nice revision section on page 136 and 137 that I want you to do. So I see you again. So we have a lesson today, grade 11s, and I see you again on Friday. Okay, and we have a Skype session on Wednesday, which is tomorrow. So what we can do for tomorrow is go over this work that we've done, and then for next week I want you to finish this revision. Okay, so by the end of this week I want you to be done with this blue revision section. Okay guys, and then we're going to start the next section after that, which is going to be on page, I'll tell you now. Okay, well, actually I've got good news for you. We are almost done with term 2's work. Well, that was actually it, which is really good. Yeah, so we're going to continue with measurement, perimeter, area, and volume. But also next week, I'm going to talk more about your assignments and what we're going to do with one of those investigations. Okay. All right, guys, I'll see you on Friday in our next lesson and during our Skype lesson tomorrow. Okay, take care. Bye.